The smallest thing in existence is a fundamental particle. We usually imagine a fundamental particle as being a point in space. However, it is equally possible that it consists of even smaller particles. But for the sake of simplicity, let's imagine that the fundamental particles that we know of are the final building blocks of the universe. A couple of the known fundamental particles include quarks. A different analogy that we can use to define these different quarks are different human experiences, like color. We use these quote-unquote colors to define their different charges. You have the red quark, the blue quark, the green quark, and also the opposites of these charges, the quote minus red quark, the minus blue quark, minus green quark, and of course, the neutral white quark. Quarks also come in multiple different quote-unquote flavors to describe what kind of quark it is. The up quark, the down quark, top quark and bottom quark, the charm quark, and my personal favorite, the strange quark. Quarks make neutrons and protons, and the protons and neutrons then produce the nuclei of atoms. The fields that you see represented around this atom are representations of electrons. These don't necessarily describe the electrons, but do describe where they might be. Here's a terrible illustration of where the electron might be. So in that case, let's talk about our next fundamental particle, which would be the electron. Electrons have a negative charge and are repelled by any other electron. They are also attracted to the positively charged nuclei of atoms. This is why you see electrons around nuclei. Every particle has what is known as an antiparticle. The electron's antiparticle is the positron. When an electron and a positron meet, they will annihilate and turn into radiation and leave nothing behind. They are also magnetically attracted to electrons as they have an opposite charge. This next particle makes absolutely no sense, so be warned. Light, as we know it, consists of particles known as photons. Here are the photons that we observe with our eyes. When you combine these three colors, you get white light. You can think of different color spectrums as different sections of a larger light spectrum. Here's a model of the light spectrum. Can you tell where visible light is on this spectrum? Ding! If you can't see it, allow me to zoom in. Yep, that's it. That's the whole thing. Our three colors make up 0.035% of the whole light spectrum, squeezed in between ultraviolet and infrared. Photons act as if they are both a particle and a wave. It is a very strange and mostly unsolved mystery, so we refer to them both as particles and as waves.